In this video, we want to focus on the final step of implementing a protocol with DKVf, which is writing the client side of the protocol. Alright, so the first thing that I do is I create a new project for the client side of the protocol. So I call it eventual client. So I first copy and paste the content of the DKVf core component from my server side to the client side, because it includes the metadata that I created with the protocol buffer and also my comparator and everything. So I just copy and paste all of these to the source folder of my client. So I also need to include protocol buffer jar file and also the BreaklyDB library, jar file, to my project. Okay, so now the client side is ready to be implemented. All right, so just like the server side, I first create a package for this side. I call it eventual consistency client. Okay, it's not really important. And then I create a class called eventual client. All right, so the client side should must extend the DKVf client class. All right, so we need to call the superclass constructor and also implement two functions, put and get. So the put and get of DKVf clients are from the perspective of the client of the data store. So client of the data store doesn't have anything to do with the other metadata like the timestamp or anything else. So the client only cares about the key and the value. And the key naturally is a string and the value is the byte array. Okay, so we need to provide this interface for the client. Okay, let's write the put message first. So this function receives a key and a value from the client, so which is the key, the pair of the key and value that the client wants to read, and it returns a boolean. So it returns true if the put operation is successful and returns false otherwise. So the first thing that I need to do is create a put message and after that the client message, and send it to the server and read the response from the server. So the put message is the put message that we define in our proto file, right? So you remember from previous video this message. So I first create a put message. So it's the protocol buffer created class, so it's has a builder pattern. So I set key to key and set value. I use byte string, copy from value, and then I call build. Now I create a client message. CM. Again, I use the builder of this class and set the put message to PM, and I call the build function. All right, so remember that we are considering partition system. So which means that in each replica we have a set of partitions. So the question is how we can find the correct partition to write this key. So it depends on our policy. Okay, so in this example I want to use hashing to find the partition, but it is not forced by the DKVf, so you can use any policy that you want. So I assume that I have a function called find partition. I will implement it later, that find the partition ID for this key. Okay, so I assume that I have this and I call it partition. So the partition variable specify the correct partition to write this key. All right, so to send the now right now, I mean our client message is ready to send, ready to be sent. So the question, I mean, we can send it using send to server function provided by the framework, but this function asks for an ID. So as we said in the previous video, this is our choice to specify the ID. So, and the mapping between IDs, server IDs, and their actual address is should be defined in the configuration file. So we can use any pattern that we want or any naming. So I like to use this. I want to have a DC ID or replica ID, and it's separated by an underline, and after that is a partition ID. All right, so I will define DC ID later, just as we did in the previous video for the server side. Now I can use send to server function of the framework that receive an ID and a message and returns a network status. So if the network status is failure, I return false. Immediately I return false because it means that my server couldn't send the message to the server. Okay, so but if it's not failure, I go ahead and read the response from the server. So I create a client reply, call it CR, and now I use the read from server function that received the ID, okay, of ID of the server. So now I check the response. If the response is not null, and if the status is true, I return true. Okay, but if it's not, I return false. So in DKVf we can write log message if we want. So DKVf has two separate logging, one for the framework stuff and the other is for the protocol. So here we, as a protocol designer, we can use protocol logger, and so it's a normal Java logger, so I can use severe or any level, and then we can specify which level of logging we want to our system use in the config file. So here I simply said that, okay, server could not, okay, put the key, and I can say which key. So for message, of course, I'm sure you know that we can use message format or string builder to be optimized, but it's just fine for this example right now. All right, so this is the put function. So what I need to implement is the find partition and the DC ID. So the DC ID is simply our ID. So the client, so the DC ID is the replica that the client refer to read the values. We also define number of partition because the client needs to know what is the number of partition in my hashing algorithm that I want to implement in my find partition. So let's write the body of the find partition. So it returns an integer, which is the ID of the partition, and receive a key, which is the key that we want to run. So the utility library, the utils library of DKVf provide a function called getMD5 hash long, which returns a long value. And so we simply send the key and it returns a long value. And what we're gonna do is return an integer of this long value. And to have, because so when we have, for example, 5 partition, we want name them with partition ID 0 to 4, for example. So I use modulo n of partition, number of partitions. So number of partitions, it should be partitions. So this function has a problem here. So in this case, I just return. So if we don't have the MD5 algorithm, I return so here I return int hash number of partitions, right? And otherwise I just log here severe. I can write, for example, exception in hashing, and I return 0 here. All right, so you can have better things here. Okay, so now this function find the correct partition by the hashing. And so hashing is good because it's a good load balancing and other good features. Many actually databases use hashing to distribute keys. Okay, so we are done with the put function. Okay, now let's write the get message. Okay, so this function receives a key, and as a return value, it returns a byte array, which is the value of the key specified, requested by the client. And if there is a problem in finding the key, we return null. Okay, so in the put message, in the put function, we create a put message for the client. Here we use the get message, which we define in our protofile. Right? So I create a get message. GM, get message, and new builder, set key to key, and build. And I also create a client message, new builder, set get message, GM, build. Right? So again, just like the put, I find the correct partition by find partition function. Partition find. Sorry. And then I create the server ID. Now, again, I do the same thing. I send to server, and if the result is failure, I return null. Okay. Otherwise, I create client reply. Read from server. If CR is not null and CR get status is true. So here instead of return true in the case of put operation, I return the actual value. So I read the response that I receive, get reply, get value, and 2-byte array, so it returned a byte array. And otherwise I return null if actually, yeah, if the status is not true, I return null. And I can have a load message here, but I'm ignoring it here for this video. So that's it. This is the client part. So we had to implement. Oh, one thing is remaining actually, which is reading the configuration file as just as we did for the server side. So again, I can read the protocol specified properties using get protocol properties of the config reader. Okay, I think I need to import Java util, same as for list. All right. Now, now I can read my variables here, and because both of them are integer, I change it to integer. Protocol properties, get num. So remember that this naming is completely depends on you. Partitions, get 0. Oh, sorry, it should be site. All right. So just like this. Oh, oops. Just like this one. I have the DC ID. All right, so that was the client part. It's unnecessary. So yeah, we had to write the put and get operation required by the DKVf abstract class.